Lesson 5.7 deals with calculating probability. Let's look at this first one. A bag contains 4 red marbles, 4 blue marbles, and 3 green marbles. Get the probability of choosing a blue marble. Well, you take the number of ways to get a blue marble, 4, over the total number of marbles, 4 plus 4 plus 3. So on our calculator, we would write it as a fraction, 4 over 4 plus 4 plus 3, and we get 0.3636, which rounds to 0.364. Next one. Find the probability of choosing a red marble, so that's 4, over 4 plus 4 plus 1, and that works out to be 0.444, repeating. A bag contains 2 red, 5 blue, and 5 green. Of choosing a green marble, so 5 over 2 plus 5 plus 5 is 5/12, which is 0.416. Of choosing a green marble, I just had the wrong answer in there. Green. Okay, now let's look at the next one. A bag contains 1 red, 3 blue, and 1 green. Give the probability of choosing a color other than red. So a color other than red. Well, we've got the ways to get the marbles is 1 plus 3 plus 1. And the ones that aren't red, there's 3 blues plus 1 green. So on our calculator, we would have 3 plus 1 over 1 plus 3 plus 1 gives us 4/5, which should be 0.8. Next one. If you toss a die, what is the probability of rolling a just a second here. If you toss a die, what's the probability of rolling a 3? Well, there's one way to get a 3, and there's 6 ways to roll the dice. So it would be 1 over 6, which would be 0.16. 6666 or 167. So these are, oops, we got another one here. A classroom has 20 women and 15 men. What's the probability of selecting a woman from the room? So we would take 20 out of 20 plus 15, oops, is 4/7, which is 0.571. Next one. We've got empirical probabilities. Empirical means from experimentation. Let's look at this first example here. Consider the following table of 157 students to tell you the probability of choosing a student in the Ag program. So we need all of the Ag program students, which are both freshmen and sophomores. So our probability would be 12 plus 30 out of 157, because there's 157 total students, is 0.268 when you round it. Next one. The table shows 100 70 phone customers, the probability of choosing a customer with a smartphone. So we want these three added together out of 170, excuse me. So another fraction, 24 plus 51 plus 24 out of 170 is 0.582, and so on. Number 3, probability of choosing an AT&T customer out of 178. So AT&T is 24 plus 25 out of 178, and we would get 0.275. Next one. The classroom has 19 women and 15 men. What's the probability of selecting a woman from the room? We already did that one, didn't we? All right. And then the last thing that we have to do is probability in genetics. A certain recessive gene has a probability of 0.9. What is the probability of the dominant gene? Well, it'd be 1 minus 0.9, which would be 0.1. What is the proportion of the population that displays the recessive gene? This one you need to have the table for. And I'll draw the table, and then you'll see how to solve this problem. The table has 4 possibilities. You have dominant and recessive, dominant and recessive. Those are the 4 different possibilities. It says the recessive gene is 0.9, so the dominant gene is 0.1. 0.1, 0.9. So the probability of DD, dominant and dominant, is 0.1 times 0.1, which is 0.01. Dominant times recessive, 0.9 times 0.1 is 0.09. Dominant and recessive is 0.09. Recessive times recessive is 0.9 times 0.9, which is 0.81. Next one. A certain recessive gene has a probability of 0.35. What proportion of the population displays the the dominant trait? Now this one is a little bit tricky, and here's why. If we've got dominant recessive again, we're doing the cross. This is 0.35, so this is 0.65. Oops, this is 0.35. So when we calculate it, we would have 0.65 squared is 0.4225. 0.35 times 0.65 is 0.2275, which would be the same thing for down here. And then 0.35 squared is 0.1225. All 3 of these are going to display the dominant trait, because if you have one dominant gene, then you will display that dominant characteristic. You don't have to be pure dominant, but you do have to be pure recessive to display the recessive. So we could add those 3 up. 0.4225 plus 0.2275 plus 0.2275, and we get 0.8775. Or we could just take 1, subtract the recessive, because everybody that's not recessive will be dominant. 1 minus 0.1225 will be our 0.8775. Either way, you're going to get the right answer. What proportion carries the recessive gene? Okay, so let's look at this one. So we've got dominant, recessive, dominant, recessive. This is 0.45. This is 0.55. Okay, these are the only ones that don't carry the recessive gene. So if we take 0.55 squared, we get 0.3025. So everybody else will be carriers of the recessive. So we could take 1 minus our answer, and we get 0.6975 is these three cases here. Next one. A certain recessive gene has a probability of 0.55. Complete the diagram. Well, you see it completed there. This is 5.7 calculating probabilities.